Let's solve this jam physics problem together. We have a ball of mass 0.1 kg which is thrown vertically upwards with a speed of 10 meters per second from the top of a tower 10 meters high. Neglecting air resistance, what will be its total energy just before hitting the ground? For this kind of problem, what we are basically being asked is to use the principle of conservation of mechanical energy. Now, for total mechanical energy, if you want to find the total mechanical energy of a body, it is always going to be the addition of the kinetic energy and the potential energy. And because it is always conserved throughout a system, especially when air resistance is not a thing to worry about. Now, this is the tower, which is 10 meters high. So we have this 10 meters high. And you are trying to launch an object from this top with an initial velocity of 10 meters per second. So the object will travel in this manner until it's about to reach the ground. For this case, we don't need to do any motion calculation, whether we need to find the time taken or the velocity with which it hits the ground and all of those things. In fact, even if we want to do that, we don't need to stress ourselves using equations of uniformly accelerated motion. We can just use the fact that total mechanical energy is always going to be conserved. And what do I mean by that? The implication of that is that whatever the total energy at this point is, that will also be the same thing as the total mechanical energy at this point. The only difference is just that, as in this case, we will be having both kinetic energy and potential energy. Why? Because for this position, the object is at a certain height above the ground, so we have gravitational potential energy, and also we are launching it with an initial velocity at this point as well, so we also have kinetic energy. So let us find the kinetic energy and the potential energy at this point respectively. Now, kinetic energy will be half mv squared, and that would be half, the m is 0.1 and the v is 10. The v is 10 meters per second squared, which is this. When you multiply all of these together, you have 0.1 and 100, that's 10 divided by 2, that gives us 5 joules. Likewise, the potential energy here is mgh. The mass is still 0.1. The g we are using here is 10 meters per second squared, and the height above the ground is 10. When you do all of these, you find the total potential energy here to be 10 joules, which implies that at this point, the total mechanical energy is 15 joules, which is the addition of the 5 joules here and the 10 joules here. Now, what happened here is that upon the moment before it hits the ground, it is no longer at any height above the ground. Therefore, it would have lost all its potential energy, and all of this mechanical energy would have been converted into kinetic energy. And at this point, the total energy just before hitting the ground is 15 joules. So the answer to this problem is 15 joules. But we can do something further, which is a bonus to you, is that we can find the velocity with which this body, this mass, hits the ground, because the total energy here has been converted to kinetic energy. Hence, we can equate this 15 joules to half mv squared and solve for v. Now, this will be 15 equals 1 over 2 multiplied by 0.1 v squared. Now, with this, that implies that v squared, we have 2 times 15 is 30, then you divide it by 0.1, which is 300. Then this implies that v is the square root of 300. Now, in short form, that is 10 root 3 meters per second. 10 root 3 meters per second. But if you press your calculator, you get an approximate value of 17.32 meters per second. So this is the velocity just before hitting the ground, or the speed just before hitting the ground. And that's how you solve problems like this. Don't forget to like, subscribe, and follow. I'll see you in the next one.